Hi there. Welcome to this practice set on forms of quadratics. I keep second guessing whether I'm saying the words that I want to say when I want to say them. I am distracted a little bit by the guy in the orange vest tinkering with the electrical stuff right outside my window. I don't know what's going on with that. Hopefully this will be the recording that sticks. So please like and subscribe for more math help. Drop a comment or question below and check out the other videos and playlists that we have on the channel. Pause the video to work these problems on your own and then come back to check your work. Okay, so remember from the lesson, we don't move directly between vertex form and factored form. There's no way to go directly between there. So we always move from one of those into standard form or out and so forth. So these problems really focus on moving into and out of standard form. The first four problems are asking you to move into standard form from the other two, and then the next four go from standard into those two. But you might remember from the video, there's not tons of problems that are nice in both vertex and factored form. Not that I can't write them, but it's easier to split those up. So these first two are moving from vertex form into standard form. And the way we do that is we square the binomial. Okay, and so in number one, we're going to do x minus 3 times x minus 3 and then add the plus 1. Now, how you want to do x minus 3 times x minus 3 is up to you. My classes do this with the area model, so I'm going to reinforce that. X times x is x squared. X times negative 3 is negative 3x. We have that twice. And negative 3 times negative 3 is positive 9. And then, of course, our middle terms will combine. So we'll have x squared minus 6x plus 9, and then we need to simplify by doing 9 plus 1 is 10. Ta-da! Now the second problem, as promised in the video lesson, we kept it to when the a value was equal to 1. But I said, check out the practice set, because the practice set is going to have some where the a value is not equal to 1, just so we can make sure that we're getting that piece too. So this one might have tripped you up a little bit. You might have been not sure, like, what should I do first? So we go back to our order of operations, and remember that exponents come before multiplication. So what that means is that you need to do that exponent right there before you do the multiplication with the 2, okay? So that's the key thing. So if you went and did 2x plus 2 and then you squared it, it's not a big deal if you do it on the practice set. You just want to go back and fix your work. So, and that does not mean erase all of it and pretend that you got it right. It just means, like, find a spot in the margin, go grab a different colored pen, or a pen if you're working in pencil, and just make that correction. Okay, it's not a big deal. But x plus 1 squared is x plus 1 times x plus 1. Now, technically at this point, you have dealt with the exponent. So if you wanted to multiply now, you could. You would just want to make sure you only multiplied it through once. So you could do 2x plus 2 and then do the multiplication with 2x plus 2 times x plus 1. What you don't want to do is multiply the 2 through both times, and here's why. If you had 2 times 3 times 4, okay, I'm down here in the lower left, you could do 2 times 3 is 6, and 6 times 4 is 24, and that would be fine. Or you could do 3 times 4 is 12, and 2 times 12 is 24, or if you really wanted to be, like, bold, you could go ahead and do 2 times 4 is 8, and 8 times 3 is 24. Bottom line is that 24 is the answer to that problem. 2 times 3 times 4 is 24. What you would not do is this. You would not try to distribute, because distributing is multiplication over adding and subtracting. It's not multiplication over adding, or not multiplication over multiplication. So if you did this, you would end up with 6 times 8 is 48, which, is, you'll notice, is twice as much as you were supposed to get, and that's because you multiplied in that 2 twice as much as you were supposed to. So what does that have to do with this problem that we're looking at? You can multiply the 2 in the x plus 1 and then take that result and multiply it by x plus 1. Or you can multiply x plus 1 times x plus 1 and then multiply the 2 in. But what you cannot do is try to distribute through both sets of parentheses, okay? Cannot multiply through both sets of parentheses. And I'm emphasizing that because I've seen it a lot. I have taught Algebra 2 and math for a very long time at this point, and I've seen that mistake happen. So I know that that's something we're prone to. I'm going to go ahead and do the x plus 1 times the x plus 1, because if I have to multiply these, I'd like to do it with smaller numbers. And so this would be x squared plus 2x plus 1. I just added all of those up. And now I'll go ahead and distribute the 2. So 2x squared plus 4x plus 2. And notice that minus 3 is just kind of hanging out, like on its way down. I haven't done anything with it yet, but I am about to now. 2 minus 3 is -1. And so that's how we could do that. Now, just because I don't know how to let something go, okay? If you did it this way, it would still work. So you could multiply through just the first set of parentheses. So you'd have 2x plus 2 and then multiply by x plus 1. Okay, and you'd get 2x squared plus 2x plus 2x plus 2, which would add up to 2x squared plus 4x plus 2. Oh, don't forget we had the minus 3. And so 2x squared, so we should go there too, plus 4x minus 1. And notice that that also works. But if you multiplied it through twice, okay, then you'd end up in the wrong place. It would be like if you went out of order and tried to do the multiplication before you did the exponent. Okay, so super common mistake, and 100% okay if you made it, just as long as you fix it and then like listen to the explanation as to why that was not the right thing to do, so you don't do it again. That's, I mean, how we learn. Now these two are going from factored form into standard form, and so these ones are just a matter of doing that multiplication through. And so I have x plus 3 and x minus 7. So that'll be x squared, 3x, -7x, and -21. And those are my two that will combine. So I get x squared minus 4x minus 21. And we just did this, so I'm not going to re-emphasize this point again. Because I just did it. So with this one, you can multiply the -3 through the first set of parentheses, or the second one if you want to do, but they're both the same. So, and then multiply that new one by the x plus 1, or you can take the 2x plus 1s and multiply those together. I'm going to do it differently this time, just for variety. So I'm going to take that -3 and distribute it through that first set of parentheses, and then use my area model to multiply that next one. So next x plus 1. So -3x squared minus 3x minus 3x minus 3. So that's -3x squared minus 6x minus 3. If you did it the other way, okay, you would have this. So you'd have -3 times x squared plus 2x plus 1. And then you could multiply the -3 through. And notice that you get the same place. And if you're wondering, how did you get that? How did you get this right here? I have done so many of these in my lifetime. I can do them in one step. I don't have to do middle steps out anymore. But I mean, you could do it out if you wanted to. Okay, either way works, but you cannot distribute it over both. Okay, cannot do that. Now, now we get more fun. So these are in standard form, and now we're going to move into factored form, and it's pretty much the same old skill of factoring that every student loves so much. So we have x squared minus 9x plus 18, and we are looking to factor that. I'm going to use the area model. So I'm going to put in the x squared and the 18, and we do 1 times 18 to get 18. And now we're looking for two factors of 18, positive 18 there, that add up to a negative 9. And so I have 1 times 18, 2 times 9, and 3 times 6 are my candidates. Right here, if that's a negative 3 and a negative 6, that will add up to negative 9. I mentioned in the video, if you need a refresher on this, I do have videos on my channel that are pretty in-depth about the different kinds of factoring, as well as a massive factoring practice set that you can work through that will go through all the different things that you might see with factoring. So go ahead and check that out. It'll be in the Algebra 1 playlist, in the Quadratics playlist, and I think probably in the Algebra 2 playlist as well. So there we go. GCF between x squared and negative 6x is x. X times x is x squared. X times negative 3 is negative 3x. And then this is the negative 6. So this is x minus 3 and x minus 6. Next one, as advertised, we are looking at ones that might have a leading coefficient, not 1. So in this one, the A value is 2. Just trying to get a little bit of review in. So this is 2x squared and this is 4. And what we do is 2 times 4 is 8. And now we're looking for two factors of 8 that add up to 9. The factor pairs of 8 are 1 and 8 and 2 and 4, and the one that adds up to 9 would be a positive 1 and a positive 8. So this is positive 1x, this is positive 8x. GCF between 2x squared and 1x is x. X times 2x gives me 2x squared. This would be x times 1. This would be 2x times 4, and then you can check it with 1 times 4 is 4. So my factors are 2x plus 1 and x plus 4. Again, check out the factoring resource. Probably not what you want to watch, in your spare time, but it is like a factoring boot camp of here's all the things with all the explanations and all the work, everything that you would need to really reinforce that skill. Now, this is the new skill. This is like the new thing that was covered in this video. This one is the one where we are keeping the A value equal to 1. For simplicity's sake, and we are moving these from standard form into vertex form. So the process on that is take your B value and divide it by 2. So negative 12 divided by 2 is negative 6. And we're going to save that number because that's the number that's going to come up when we go to do that factoring the trinomial step. Then we take this number and we square it. Negative 6 times negative 6 is positive 36. And that number is the number we are going to both add and subtract. And so to complete the square, we're going to add 36 right in there. But we cannot just add a 36. We would also need to subtract a 36 in order to keep this equation the same as it was before. So if I add in 36, I've got to subtract 36. Then this is my perfect square trinomial. And you could go through the process of factoring, or remember that we saved that. So it will actually be x minus 6 all squared. And then 26 minus 36 is negative 10. So there we go. All right. And Last but not least, for these problems, we have y equals x squared plus 6x plus 14. We're going to take that b value, divide it by 2, so we get 3. We're going to save that number because that means when we're all said and done with this, we're going to have x plus 3 all squared, okay? So that's what that 3 is there for. We're going to square the 3 to get 9, and that's the number we're going to be adding and subtracting. So we're going to add the 9, and then we are also going to subtract the 9. Looking at our perfect square trinomial, that is x plus 3 all squared, and then 14 minus 9 is 5. And now we have completed the square. Now, what I might do is an enrichment video at some point where we look at completing the square when maybe you have an odd number or you have a leading coefficient that's not 1, just to show that it does work. It just gets awful. And so if it's not a skill that we need to have, we don't typically spend a lot of time on it. Now, these two are meant to be a little bit more practical, like for our multiple choice kinds of things, or just if you have access to a graphing utility and you want to check to see whether your work is right. You can use Desmos to check whether the following are equivalent forms of the same function. So let's say you had this one here, and you wanted to put this into vertex form. Now, with that leading coefficient, that is actually not going to be a nice process to do there, okay? It's just not a nice process to do. So you carried it out, but man, it was super messy. You want to know, did I do that correctly? So what you would do is you would graph them on Desmos. So right here, you can see in purple, I have 2x squared plus 4x minus 3. And then in the black, I have y equals 2 times x plus 1 all squared minus 5. And you can't see the purple graph there, but that's because the black one is right on top of it. If you have just changed the forms, that's all you've done. It's the same function. It just looks different in terms of like what form it is in. Now, if you weren't sure, what you could do on Desmos is click the little gear up there and expand the table for each of them. Or you could simply turn off the visibility on the black one to make sure that the purple one was indeed right underneath it. So you know that yes, those are equivalent forms of the same function. For number 10, we've got the negative x squared plus 4x plus 14 and negative x minus 2 all squared plus 10. And what you want to notice there, we have the red and the blue. They are clearly not the same function. So something happened in there that indicated like that it was an error, okay? And so for the first one, we would say yes, those are the same function. For the second one, we would say no, they are not. And that's a really useful technical skill with that, to be able to graph to check your answers. You can use this on a multiple choice test to eliminate the answer choices. You know that you're looking for like something that generates the same graph if they are equivalent functions. So please don't forget to like and subscribe, or you could like a subscribe. I don't even know what that would be. Like and subscribe if you found this video helpful. Drop a comment or question below, and check out the other videos that we have on the channel, including some of the other explorations of completing the square. I'll see you in the next one.